What's going on, guys? Starting a little bit late today, but not too bad. How's everybody doing? Why isn't my iPad not showing up? Hey, what's going on, Alyssa? Hey, Maggie. How you guys doing? There we go. So, today is just going to be some review stuff that we did from last week, because technically, after lesson 9, we are going to be going into a quiz. Obviously, I'm not going to give you guys a quiz while you're stuck at home. So what I did is I just changed it into a lesson and a homework. So the lesson you guys should have been able to download on your iPads. If you need it, just let me know and I'll send it your way. The homework I just uploaded to the iPads earlier today, and the homework was originally a quiz. So everything that is on homework number 10 are from homeworks numbers 7, 8, and 9. So if you need to go back and look at those to get some extra guidance on how to complete these, you may do so. I'll still help you guys out on it if you guys have any questions. But what I planned on doing is I'm just going to go lesson 10. I think what I'm going to do is I'm just going to do the first 2 questions today. I'll do question number 3 and 4 tomorrow. And then you guys have the opportunity to work on that homework number 10, which will be due on Wednesday. Okay? So, first 2 problems is just talking about domain and range. And I'm going to show you guys how you can find each one of these. I'll do with the use of a calculator, without the use of the calculator, just so you guys understand what's going on. The domain ones are always going to be the easier ones to find, because domain is representing the x values. And when you are working with, especially the first 2, the fractions, you cannot have a denominator that is equal to 0, because like we said in the lesson last week, anytime the denominator is equal to 0, it's undefined. So what we need to do is find where it's undefined first, and then we can state the domain. So we're going to find the undefined. So in order to find the undefined, what we were told is, hey, just look at that denominator and find a value that you can plug in for x that makes it not work. Algebraically, what we did is we just took that denominator and we set it equal to 0. And once you set it equal to 0, you can subtract 8 from both sides, and you guys should see that x is not going to be equal to, x is going to be equal to -8, which is not allowed to happen, so I got to put a little line between there. Because if you plug that in, -8 plus 8 is 0, and we're not allowed to divide by 0. Okay? However, they're not asking for the undefined, they're asking for the domain. So now all we have to do is write it inside what we called set builder notation, which we did with squiggly brackets. So I'm going to make my squiggly bracket. And since we're looking for the domain is all of the x values. And then we did a vertical line that represents but. So it's all the x values, but x cannot equal -8. And that is a proper representation of the domain for part A. Okay. B, same type of problem. I'll run through the same exact steps. Once again, you're looking at the denominator and you're just setting it equal to 0. Your goal is to get the x all by itself. Doesn't matter how you do it. What I'm going to do, so I can do it in one step, is I'm going to add the x over to the other side. And if I add the x over to the other side, I'm going to have 4 is equal to x, which again, if you plug in +4 for this x down here, you're going to realize that you're going to get 0 again. And that's not allowed to happen. So this is not allowed to happen. X cannot be equal to that 4. So once again, we're just doing our squiggly brackets. Everything's going to look exactly the same, except I'm going to switch it around so the x comes first, and we're just saying x cannot equal 4. Because it doesn't matter the order you put it in. If you want to put the x first, you can. If you wanted to put the x second, you can as well. They mean the same thing. Okay? So you'll have a couple, I think there was like 1 or 2 of those questions on the homework. Part C is going to be the same type of problem, except now we're working with square roots. And when we have square roots, there's 2 things that are not allowed to be in square roots. Actually, I'm sorry. There's only 1 thing that's not allowed. I don't know why I said 2. There's only 1 thing that's not allowed to be in a square root. We're not allowed to have negatives. So I'm going to write no negatives under the square root. And again, this is similar to what we did. Actually, I said 7, 8, 9. This might have been from lesson 6, if I'm not mistaken. I could be wrong, but I think it was from lesson 6. Could be lesson 7. I don't know. I don't know about you guys, but these last like 4 or 5 weeks now, I can't believe it's been 4 or 5 weeks. We've been doing it on the computer now. This is getting ridiculous. But anyways, we're not allowed to have a negative underneath the square root. So what we do is we have to say that we're looking for everything that is greater than or equal to 0. It's got to be bigger than 0 because it's positive. And 0 isn't positive or negative, so it's okay for us to make it equal to. So now what I'm going to do is I'm just going to solve that, and we just care about what's underneath. Because if you square both sides, that's what you're going to get. Because the square and the square root cancels out, and then the 0 squared is still 0. Now, I'm just trying to get that x all alone, just like we did before. So, I'm going to subtract the 9 over to the other side. I'm going to have negative 3x is greater than or equal to negative 9. And then we have to divide everything by negative 3. Just remember, when you divide by negatives with inequalities, you have to flip that inequality around. So this is going to become x is less than or equal to 3. So again, I'm just going to put in a squiggly bracket. So I have x such that x is always going to be less than or equal to 3. And we're done. So the domain for part C is a little bit different than A and B because you're not setting it just equal to 0. You also have to make it greater than 0 as well because you can't have those negatives under there. Okay. So the only other one I'm going to do is the range. This is what we talked about in lesson number 9 when we were working with those graphs. I'm just going to kind of jump back to it really quick. So lesson number 9, when we were doing the range stuff, this is when we were working with the hyperbolas. So the range can always be determined with the k value. And that's if there is a number that falls at the end. So I'm going to do a little bit more practice with these ones just because we didn't spend a lot of time on this in lesson 9. But if you were to look at this one, we said that the k value was negative 1. And if you come down here, I said y is equal to negative 1, which really meant on our graph, y equals negative 1 was not allowed to happen because as you see over here, we created something called an asymptote. So I'm going to go back to this lesson. And I'm actually going to start with part C because part C was just like number 1 on lesson 9. So the first thing that you have to do is recognize what the k value is going to be. So that formula was given to us in lesson 9, but I'm just going to draw a little arrow here, and I just want to point out that this 4 is represented by k. Now when you're looking for an asymptote, y is equal to that k value. And that just means that when you find that solution, when you find out what k is, that means there is no answer at that y. So I'm going to write down y is equal to 4, since we know k is equal to 4. So again, this right here is called an asymptote. This means there is no solution at y equals 4. Okay. So these can be found using a calculator. I'm just showing it algebraically for now because I want you guys to recognize where the number's coming from. Now, if I go to set up my squiggly bracket like we did up top, this time we're doing range, so you just have to make sure you're doing the y values. So we're saying that all y values work, but we have that y equals 4. Now, I can't say y equals 4 when we go to write it as a range because we said that there's no solution there. So that just means we have to put a line through it. So we're saying all the y's work, but y cannot equal 4. Okay, so this one was like question number 1 on lesson 9. Or number 2. I'll have to go back and check it in a second. So I'm working my way backwards. I'm doing C, then B, then A, because that's how we kind of did it in the lesson. I want to be consistent with you guys. So B, so again, I'm going to go back to lesson number 9. B is actually like example number 3. Now, if you look at example number 3, it's written just as a fraction, ax plus b over cx plus d, and there was no number added on or subtracted at the end like the one we just did. They said that if you wanted to find the range in this one, or if you wanted to find that asymptote for the y value, y is equal to a over c. So that's the important one when you just have a fraction. Okay, so I'm going to go back to number 10. So this one is question number 3 on lesson 9. So our goal was to try to figure out the a over c. And if you look at this fraction, it's in the same exact form as question number 3 in the notes the other day. The a value is just represented by 4, and the c value is represented by 2. So I'm just going to plug them in. So y is equal to 4 over 2, which just means y is equal to 2. So just like part C, that number we just found is our asymptote. Now that I have my asymptote, I can put it inside the squiggly bracket just like we did in part C. Because there's no solution there, I'm still looking at the y's. So all y values work, but we said that 2 is the asymptote, so there is no answer at 2. Okay. So now I'm going to do the very first one. Now the first one's the easiest one, and I'll explain why in a second. But I want to make sure that you guys feel comfortable with those two. Those are the two that we did in lesson 9. We're going to do some more of them tomorrow as well. So if you're still a little lost with them, number 3 is going to do some more practice with domain and range, and number 4 is going to do some more practice with domain and range. But we'll do the graphs tomorrow, like I said. Part A is actually the easiest of all 3 of these, because if you look at this one, it is not like question B, and it is not like question C. So it's not either one of them. I'm going to type it into the graph to show you guys what's going to happen here. Oops, I always hit the wrong button. So I'm going to go into my fraction. I'm just going to type in 2 over x plus 4, and I'm just going to hit graph for you. Now, the reason why I say this is the easiest one is because when you're looking at the y values, if they're not in the form like part B was, notice part B had x's on top and bottom. Part A does not have x's on top and bottom, so it's not like that question. And if you look at the last question, it's very, very similar to part C, except part C had that plus 4 at the end. So this one's a little bit easier because there is no number at the end. And in math, when there's no number represented there, we always called it 0. So technically, there is a number there. There is a k. We're just saying it's 0 because there's nothing there. So really, I guess you could say part A is more like part C. If there's no number there, you can just say it's 0. If you have x's on top and bottom, like in part B, then you'll have to go that direction and say y is equal to a over c. So in this case, we could just say y is equal to 0. And then we could do our squiggly brackets just like we did. It just means the asymptote is going to be at 0. And if you guys look at the graph here, I can't point at it on my calculator, but if you look at that x-axis right here, if you look at that x-axis, the green line is never going to cross the x-axis on either side. So we're allowed to say that asymptote is at y equals 0. So just going to do the squiggly bracket one last time. We have our y such that y cannot be 0, otherwise it fails the graph. Okay? So that is all I got for you guys. Simple as that. Okay? So if you guys got a question, I'll kind of chill for a little bit. We'll do the graphs again tomorrow. If you felt pretty good with the graphs from lesson 9 and homework 9, then you'll probably be able to go right through it and you don't need to be at the lesson tomorrow. But I still want to make sure that you guys are turning in your homework. I haven't gone in and graded 9 yet. I think I'm up to 8. But for your class, I don't even think I put the zeros in yet. So just be aware if you have not turned in homework 6, 7, or 8, and then today 9 is due. If you haven't turned in those 4 assignments, by the end of tonight, I'm going to start turning those into zeros. So if you got questions on them, feel free to stop by during my Zoom office hours, 1 o'clock every day. You guys are getting the reminds. Yeah, I'll see you tomorrow, Hannah. Yeah, hopefully the mic doesn't echo. Like I said, put something underneath it. I think the cloth is making it echo from your phone. I think that's all it is. Or it's probably because you have an Apple iPhone, and we all know, iPhones, I don't have to say anymore. Oops. But I hope you guys have a great evening. I will see you guys tomorrow. If you guys are watching on YouTube or if you're watching those Twitch, again, don't be afraid to email me if you have questions. A lot of you guys are not emailing me. All right. So I will catch you guys later. Have a good one.